Good afternoon, everyone. My name is Dave. Yes, I am from Google. It is very nice to meet all of you. Thank you very much for inviting me this afternoon and coming to see me. Please be aware I am highly cognizant that I am the person standing between you and the reception, so I promise to be a good steward of time. I also acknowledge that some of the things I'm going to say this afternoon, not all of you will agree with. That is completely fine, too. What I'm describing is an approach to solve a problem we have encountered that I think is broadly applicable to our entire profession. But you may disagree, and that's okay. That's what the Q&A is for. I will try to leave some time for that. Let me start with a couple of disclaimers. Since I'm talking to my brethren and sister in engineers in the audience, and we all like details, let me start by saying that yes, I understand that reliability and availability and uptime are not all the same thing. That we can have a principled and reasoned conversation about the differences in relative values of MTBF versus MTTR, and that's all fine and reasonable, and that is not this talk. Mostly I'm going to use these terms interchangeably in this presentation, glossing over some of the important differences because they kind of don't matter to the point, and when you hear me use the word reliability, it's the larger bucket with a capital R that encompasses these things. But know that I am aware that they are different, sometimes in subtle and sometimes in not subtle ways. But we needn't bike shed on that. There will be plenty of other things to bike shed on, I promise. Second disclaimer is this talk is very focused on engineering software systems and software delivery, but its principles, I think, are just as easily applicable to the delivery of physical things, hardware or manufacturing supply chains, things like that. But just for the sake of examples, we're going to use software since I'm a software engineer, and that's my experience, and I imagine most of your experience as well. Okay, so let's kick in. All new companies are, well, new in the beginning. And in the beginning, the people who founded and the original engineers all have this idea for this awesome application that's going to be the greatest thing since the last greatest thing, whatever that was, right? All the way back to sliced bread, maybe. And so we pour our hearts and souls into that. So just to pick a random, not particularly, meaningful example of a thing we might talk about, just to make it concrete, let's take, I don't know, search. Say you were a company who was going to do search. Okay, so you pour your heart and soul into build this customer-facing application called search. And then you launch it. And if things go well, you get users. You like users. And if things go really well, you get lots of users. That's even better. Software applications, like a lot of things, like most things I would say in the world, are governed by network effects, which is to say, the more people that use them, the more valuable they become. It's the joy of network effects. Okay, so now you have an application, you have lots of users, and if you get lots and lots of users, you kind of have a business, and if you have a business, then making sure your users are having a good experience is really, really, really important. So we say, hey, this thing needs to stay up. It needs to be reliable. So we go find some of our engineers, or maybe we go out and hire these magical unicorns, which we like to call SREs. There might be, again, we're not going to get, talk is not about the differences in the way companies implement DevOps versus SRE versus some other thing. These are humans who are principally responsible for the reliability, availability, uptime of our application. And this is a relatively simple model, and if you've ever been in a startup, this is an easy thing to understand. You have users, you have your application, and you have people who are responsible to make sure the application is serving so that your users can have a good experience. So far, so good. Funny thing about entrepreneurs. Entrepreneurs are optimists, or possibly pessimists who aren't good at math. It depends on your point of view. And they look at it and they go, and human brains are pattern matching algorithms. We like to draw lines, connect dots where they aren't necessarily there. And so the optimist entrepreneur humans look at this and go, we have this very successful application. You know what we need to do? We need to do another one because this was awesome. We can clearly do a second, right? So again, pick just sort of a random thing, no particular relevance in the world. Let's say, oh, mail. That's not hard. So now you have two applications with lots of users and people responsible for them. And still, this is a reasonably simple sort of environment to reason about. The other thing humans are great, especially engineers, that's why I love being an engineer, is we hate inefficiencies. back to our pattern matching, right? Some engineer will look at those two applications and go, you know, they share some requirements. Say storage is a good example that, you know, a search engine and an email service might share. You know what we should do? We should refactor, right? We should go pull out of those systems and harmonize, right? Bring together their storage requirements into this thing. We'll describe this thing in a minute. Okay, but before you know it, you have just hit a very, very steep and important stepwise function in the growth of your company. And it snuck up on you because this looks like an engineering problem, and it kind of is, but it introduces some things that are pretty important. Mostly roles start to get squishy. You see, before you refactored, you had users, and you had applications, and that was all good. But after you refactor, it turns out now your applications are also users, and they use this new thing you just created called a platform. All right, for the purposes of this conversation, I want to posit two simple definitions. They are intentionally simplified. A platform is a system with an API, period. That is the definition of a platform. An application is a system with a user interface. Platforms are talked to and consumed by machines. That's what an API is for. UIs, applications have UIs, user interfaces. They are communicated with humans. These lines do get blurry, I acknowledge, but just for the sake of this talk, a platform is a thing with an API. Okay? Anyone have a serious religious objection to that? Like we can fight that out right here, slide 3. No? All right, cool. Awesome. Nice thing about the end of the day is everyone's a little more pliant. All right, so the next thing that always happens is the cognitive load to do these things gets hard, either because of actual just load of, you know, keeping the number of moving pieces, or maybe the complexities of worrying about the reliability of a platform versus an end user system. So teams split, right? They go through some kind of team mitosis. So you have maybe 2 SRE teams. But more importantly, what you have is you have some definition of scope. This is one way to do it. SREs for platforms and SREs for customer applications. It's pretty common. Sometimes you'll see it as SREs for front ends versus back ends versus API servers. That's kind of up to you. It depends on how your work splits, but this is a pretty reasonable simplification and abstraction. Okay, so far so good. How many of you think this generally describes your current situation? Because there is another step. All right, I see a few hands. Good. Somebody wanted, when we think about the trends in our industry the last few years. Well, let's go back to first principles. What did we say? Applications are particularly vulnerable to network effects. The more people using an application, the more valuable it is. We can all agree on that. So I have an application that's got a ton of users. If it's a popular application, other people are going to want to connect, have machines talk to the application. And you might want to have your application talk to other machines that aren't yours, because that's a channel to more users. Again, network effects, right? It's exactly the same reason why connecting computers makes them more valuable than just the sum of their connections. And so this has been the thing that's been happening over the last few years. It's basically APIs as far as the eye can see. Every application is getting an API now, right? And that's been a kind of a tipping point over the last few years. I would say 5 or 6 years ago, it was pretty common in the industry to see applications that were only front end, only user-serving things. Those are the only people we expect to interact with it. Now we have APIs for just about everything, and it's growing. And again, it's the obvious business physics about network effects. So it's a logical progression. Okay, well now we've introduced another complication. The business requirements introduced new complications. So we had users, cool. We had applications, fine. Our applications are also users using this thing called a platform. Okay, more complicated, but it was all at least within the 4 corners of our company. Crud. But now our applications are themselves also platforms. You know that mitosis you did to split your cognitive load? That got fuzzy again. It's a little harder now. This is the second important stepwise scaling event in the growth of a company. And it's one people have a hard time dealing with. And we want to talk about how to reason about this problem, because it introduces challenges that are different than the first stepwise problem. So I like to think about hard things just from a set of principles. Set of first principles and reason forward from there. I hope you do too. Principle 1, don't think there'll be much controversy about in this room with a bunch of SREs, but if there are, I'd like to hear it. Anyone want to disagree with this? The most important feature of any system is its reliability. Understanding I use reliability as a bucket of things. My argument here is if it isn't reliable, no one will use it, and so who cares about the rest of the features? You want to disagree. I see it. Disagree with me. Sorry, it has to be reliable enough. Well, we're going to get to that in a minute. I'm a Google SRE. I believe in error budgets. I believe you shouldn't ever try to engineer the thing to have 100% uptime. That's folly. There is no system that's ever been created by a human with 100% uptime, and I defy you to point a system in nature that has 100% uptime, but we can have that argument, and yes, I am including the sun. But that's principle number 1. You think I'm kidding? Like, even if you want to count, the times we're not facing the sun as scheduled maintenance, is that what we say? Outage, planned outage windows. Clouds cause serious network disruptions. For your sun, ask anyone who ever tried to build a business on solar. They will tell you. Okay. Actually, that's a good example. So that leads me to point number 2. So thank you for that. Principle number 2. Ready? Our monitoring does not define our reliability. Our users do. Our users couldn't care less if our logs say we are delivering 5 nines if their experience is 2 nines. I ran support globally for Google Cloud for a couple of years. I'm going to tell you a conversation I never had once. Hey Google, I think there's like a thing in your system, I'm having a problem. Us. Golly, we're looking at our monitoring, everything looks hunky-dory to us. Customer. Oh, I guess it must be me. Never mind, thanks. Anyone ever have that conversation? Yeah, that doesn't happen in the real world. So this is the thing. If reliability is the most important feature, how do we reason about it? We reason about it from the perspective of the user. The rest of it is nonsense. Why? Because the value of our application comes from the users. If they don't trust it, they won't use it, and the value will go down, and our business will die. Basic business physics. Okay. Yeah, so here's where things start to get a little wonky. We have our users, we have our applications are also users in their platforms, like God, and we have platforms, and oh, now some of our users are also applications. They're machines. This introduces a very difficult problem, and I want to propose a solution to it today. The problem it introduces is the experience of the customer, the person who is building an application against your platform, because remember, if you have an API, you are a platform. Their reliability experience isn't constrained by the 4 corners of the job you do as an SRE. You give it 5 nines, well, they'll be happy. No. It is a cruel, multiplicative product of your reliability, the reliability of the platform, and the reliability inherent in the thing they build on it. Bring 2 nines to my 5 9 platform, you know what you'll get? Slightly less than 2 nines. Math, sorry. Now, when I talk to people about this, I immediately get a thing. I'm fine. My application doesn't have an API. This is a thing that doesn't apply to me. I'm being recorded. I can't use the word I want to use, so let's just say I'm going to push back on it. In the age of bots and scrapers, every popular application has an API. It just might not be an official one, including your web UI. Sorry, them's is just facts. Now, you may decide you don't care if you don't have an official API. I'm glad you think that. You're wrong, by the way. Life will teach you that you're wrong, and I'll give you an anecdote. Pokemon Go, maybe you've heard of it, right? It was this thing, and it launched, and it was great. Okay, so it launched, and everyone knows it was maybe a little rocky for a couple of days, and then it settled down, and the arc of the story is, and then they went to Japan, where it was going to be the 10x launch, and it was smooth as butter, and that is all true. But I can tell you that after the initial few days of stability issues were kind of worked out, the #1 complaint I heard from users was, ready? The third-party service that is scraping the Pokemon Go servers and telling me where all the awesome Pokemon are is down. Not the thing Niantic wrote. No, that's fine. It's the third-party thing that's not officially supported. is down. They didn't have an API. Well, they did. They just didn't have an official API. You're in that situation too. So it's cute that you think you don't have an API. Oh, you have one. The question is whether you choose to support it or not. And I'm going to argue because of the network effects, eventually you will have to support it. This is just you're just maybe not quite that far down the river, but you are floating in that direction, I promise. All right, next objection I get is, well, this isn't really a thing. Like, we'll tell customers how to do this wisely, right? We'll, like, give them white papers and best practices and deployment guides and code samples and books, and it will be awesome. Anyone think that's enough? Yeah, it's not. When we all know it's not, because these things are all subject to some level of interpretation. And they always seem to be interpreted contrary to what you intended. And we're going to talk about where this is great, but it falls short. And we're going to talk about why. Principle 3. See how everyone likes this. This is my shorthand. My good friend Niall Murphy I've sent this out for review, and he gave me a couple of nits, which I will address in the talk track, I promise, Niall. But this is the mental shorthand I like to tell people. To get a 3.9 system, you need well-engineered software. But by the way, well-engineered software is almost enough by itself to get you to a reliably 3.9 system. Asterisk, asterisk, asterisk. If you want a 4.9 system, well-engineered software is not enough. You have to have well-engineered operations, and we will talk about why that is. And if you want a 5.9 system, those two are not enough. You have to have a well-engineered business, which is to say, your business needs to know how its business objectives tie to your system SLOs, and then those to your SLIs, and those to your error budget. That's how we reason about trade-offs we have to make. Do we trade money for reliability is one thing. That's the mental framework, and I think it is largely true. Niall pointed out to me that, well, no, if you build a system, on a relatively stable platform and it doesn't get much use, you can get 4.9s. My counter argument is, right, that's the theory of no one showed up. It's not a very valuable system, by the way, if no one's showing up, but I'm going to address it anyway because I think it's mistaken. Because somebody built the mostly reliable platform on which your system is running. If that mostly reliable platform turns out to be not mostly reliable, you won't get 3.9s, or you won't get 4.9s. Right? So, I mean, the design of your system encompasses the platform choices made by a platform you picked as well. Okay. Basic math, everyone should crush this. It almost never gets crushed when I talk to customers, though. If we were to calculate our error budget, how much unavailability over 30 days are we permitted if we have a 3.9 system? Anybody remember? 43.2 minutes in a 30-day measured period. That is correct. 4.9 system. Come on, it's 1/10, right? 4.32 minutes in 4.9 system, and of course 0.432 minutes, otherwise known as 26 seconds, in a 5.9 system. All right, so network effects. You want access to all those users. They want access to your application. Other applications want access to your application. So it creates value. So far, so good. The people consuming your API are themselves going to want to write systems and have systems that are in some way business critical. And while it is true, many systems, 3.9s is enough. Most of your customers will tell you that it's not. They want 4.9. They'll say they want 5.9s. That's a nice aspiration, but the thing they really feel like they need to live with is 4.9s for their business critical things. So they want to build a 4.9 system partially dependent on your platform. So we're going to concentrate on that. So from all of this basic math, I come to an assertion. Here's my assertion. You ready? Your platform customers, anyone consuming your API, anything that's in their user's server path, anything upon which they are relying, can only get a 4.9 system by luck if you don't have some kind of shared operations with them. Well, that sounds scary. Shared operations, I don't like that. I'm having a hard time keeping up with my own workload. What the heck does that mean? This man is crazy. Okay, how does that work? Well, it's math. 4.9 system, 4.32 minutes a month. If the form of interaction with your platform customer is, hey, I see a problem. I would like to notice this problem. I would like to collect data about this problem. Now I'd like to file a support ticket. Now someone in your team gets this support ticket and asks for more data. Anyone think you can do that in 4 minutes? Right, of course you can't. We all know that's not true. Which leads to one sad, inescapable conclusion, which is if you are a platform business, and again, my theory is if you don't think you are now, you either are and don't know it or will be pretty darn soon. It's just the way the world is working. You have to SRE your customers, and that sounds super scary, and it sure was for us at Google, and now I want to talk about what that means and how we reasoned about it and do it in a sane way. Think about it in stages. Okay. So you got to go talk to your customer. You want them to make sane choices. How do you start a conversation with a customer that you don't control, right? They're not in your organization. You can't give them a mandate about how you build a thing. Okay, the way we like to do it is we conduct what we call application reliability or application readiness reviews. If you read the SRE book, these are like PRRs, production readiness reviews. Where you go in and actually deeply inspect the applications of theirs that are critical to them, or at least the components, that are relying on your platform. This is the most important thing you can do. All right, what does that mean? Well, a way to think about this is to start with a set of questions. My favorite set of questions to ask customers, because it always leads to a really awesome conversation. My favorite question of all time. Hey, what reliability is your system getting now? Well, I'm getting 3.5 nines. Really, can you prove it? I beg your pardon, can you prove it? What do you mean? Show me data. And what you quickly discover, what we always discover, and this is true for any organization, you have this in your teams, I'm sure, too, when you started an SRE journey, is you find they are measuring the wrong things. I find, on average, when I talk to people and have this conversation, we dig into it, that roughly 1/3 of the things they are measuring are not useful about reasoning about the actual availability of their system. I also find that they don't have SLOs that are tied to the business objectives. Which is a bit of a problem. Right, so they are measuring and alerting, therefore, on things that don't much matter. That means you are getting support tickets about, like, I don't care that the CPU spiked unless you can show me that that relates to something my end user cares about, like the latency went up or the error rate went up. The rest of it I don't care about. Like that's, right? So the golden rule, as we all know, is alert on symptoms, not causes. Alerting that the latency went up at the 50th percentile, the 90th percentile, or the error rate is spiking. That's a good alert. That's useful. That obviously supports some business objective. Alerting on a spike in CPU or memory pressure, maybe not so much, unless you have excellent historical data to show that that is a reliable leading indicator. Pro tip, usually isn't. Just saying. All right, so the next obvious question is, well, what are your SLOs and SLIs? That's where the glassy stare comes in, right? Because you've already told them that like 1/3 of the things they're monitoring probably aren't worth monitoring and alerting on because they're cause-based, you know, the things we know how to measure and alert on, so that's what we do because it's easy, but not right, because not everything is a nail, even if you are a hammer. Then the really awesome discussion, what are your SLOs and SLIs? Hey, what reliability, what availability does this system need to have for your business? And what you find is most teams, most customers, even the really smart, and I mean really well-developed, really rigorous, good engineering teams, and let me tell you a myth in the world which I want to shatter today. Large enterprises, which is where I have this conversation a lot. I know we have this vision of they're all ex-COBOL programmers or, you know, whatever, visual basic. No, that's not true. These are sophisticated, good software engineers. Sometimes they exist in a culture that's not very conducive to these things, but that's our job, is to help change that for them. But these are smart people that are capable all by themselves mostly of building those 3.9 systems. All right, so we should pop that myth right now. But we do find a lot customers, and we find this in internal Google teams, by the way, too. I'm not just, you know, platform customers. That customers have implicit rather than explicit SLOs, right? We all know the saw. If you don't have an explicit SLO, your SLO is the performance that you have generally, the customer has generally experienced over some measured period, which is bad. And that they're only intuitively tied to the business objectives. Yeah, latency is bad. Why is latency bad? Customers don't like it. Yeah, that's an intuitive tie, right? Because we can't really quantify what our target should be there. And then we get into this all the time. And these steps right here, this is months of conversations with the customer. We haven't really had an architectural conversation or a code conversation yet. This is the most important thing to sort and get right. Why? You need this or your customer will forever have unrealistic expectations about the performance of your platform. The reliability of your platform is important, but most important is the reliability they perceive. And if they're not strictly measuring it in a way and tying it to SLOs, then that perception is just that. It's a perception based on intuition. Do you know what you can't engineer an enhancement for? Intuition. So you need to move your customers along this journey. You have no choice. And if this is all you do, we'll put that in finger quotes, you're in good shape. Like, you're doing a good job. This is a very good place to get a customer. You will get customers with better expectations. But there is a stage after this, which is important. Stage 2. You know how it's important? It's greater than stage 1. Shared monitoring. You must have shared monitoring and alerting with your customers. A single pane of glass that tells everyone all the same things. It is a common source of truth between teams. It's math. Customer says a bad thing has happened, they file a ticket. You know what you don't want to do? Argue about whose fault it is. You know how you don't do that? You have the shared monitoring system with all the same data between you. Better is the shared monitoring system actually auto-cuts the ticket on behalf of the customer. No human required, right? You already knew what you were going to alert on. Well, I mean, you can alert the human, but just cut the ticket while you're at it. Better still, can anyone think of what even better improvement would be for a shared monitoring system? Something that fixes it, thank you. That's actually pretty close. Yeah, if your customer has a safe, reliable, idempotent rollback mechanism, just have the shared monitoring system kick it off, and then they can go and do the post-mortem afterwards. But the math can't work. You can't get 4 nines by anything other than luck if you don't do this. Full stop. Okay, by the way, shared monitoring is everybody's bestest friend. Your bestest friend, their bestest friend, it's everybody's BFF. Okay, so we did the math. You can't do 4 nines without it, right? That's too much work to expect a human to do. Helps eliminate the blame game. Remember, it's about the reliability your customers perceive in your platform, because they will act on their perceptions, not on the data. Now, you'd like their perceptions to be informed by the data. That's the thing you're aiming for. But at the end of the day, the proximate cause for their decision are their perceptions. This helps eliminate the blame game. It's your fault. No, it's your fault. No, it's your fault. That friction, gone, if you did this right. By the way, a good endpoint rule for this, customer operation team, you may not be alerted on anything that isn't in the shared monitoring console. Rule. Why? No secret data. That's a very important litmus. If you can get to that place where when bad things happen, because bad things will happen, that all the data is there and they haven't been noticing, metric foo when you've been looking at metric bar, that's a great place to be. You get rid of the blame game. So it's very important for their perception of your reliability and in your company. Also, any of you ever had to build a black box probing network for a system? Right? These are computers we set up to try to tell us how does it look externally, this application, this platform, to the world. And what do you want to do? Well, you want this thing to mimic the way the users see it. So we spend a lot of time and effort trying to get the probers to send workloads and tests that simulate common user traffic patterns, and it's fine, but it's guesswork and it's a lot of voodoo and it's expensive. If you do this, especially with your top customers, you have the greatest black box probing system ever, because you're sampling actual data instead of contriving it, right? I don't have to worry about how my 10 top customers are experiencing my platform. I have their data for it. And for your internal SRE teams, the people doing your back-end systems, this is gold. Love you for doing this. Stage 3. So we've gotten through shared monitoring and the ARRs. Cool, stage 3. All right, next thing you need to do is you've got to practice some operational rigor between the teams. Like, you will need humans to do things. If you don't practice it together, they won't get done well. And you have a very narrow window for your error budget. So the good place to start are joint post-mortems. I know we've had talks on those at SREcon, and I won't go belabor them too much. When a bad thing happens in your customer experiences, you do a post-mortem. But you don't just do an internal post-mortem, you do a joint post-mortem. That is different than the internal post-mortem you did, which you share with your customer. That's unidirectional. That's not good. You need a joint post-mortem where the customer is contributing data and action items. You are assigning things to them, They are assigning things to you. It goes in both directions. This is a really important point. We'll talk about why. And then with any good post-mortem grooming and collaboration, you need to periodically review all the AIs, make sure they're getting done. Quarterly is kind of the minimum. Monthly would be better. So let's dive in on that just a touch. All right, important rules of the road for post-mortems. You own the joint post-mortem process. You are the incident commander. You, not the customer, you. Why? What's important to you is the reliability they are perceiving of your system. You need to be able to encourage them to do actions that they might otherwise not want to prioritize. And your lever for doing that is the post-mortem, the AIs in the post-mortem process. You drive that process. If you leave it to them, you will forever get into a death spiral of, when can you finish the post-mortem? I would like you to finish the post-mortem. It would be good to see action items in the post-mortem. You drive it. I will argue a little later that doing this activity for a customer, you should not charge extra dollars for it because it's not professional services. We'll get to that argument in a minute. But it preserves your ability to come to the table with a strong opinion and then see it acted upon. Red flag. If a post-mortem doesn't have an AI for each of you, at least one, it's a red flag. You probably did it wrong. I know what you're thinking. Well, there's actually an easy way to reason about this. Let's say we, or us, we broke something. An AI for the customers, what might they do in their system to be less susceptible to this class of breakage? Again, classic defense in depth. What about the other way? This is where I normally hear an objection. The customer just screwed it up. They deleted their database schema. Had nothing to do with us, all them. Really? There was nothing we could do in the platform to make it harder for them to do a destructive change? Do a bad thing? Really? There's nothing we can do to warn them? There's nothing we can do to make the default choice the safe choice? I believe this might be theoretically possible, but I have to be honest, in all the postmortems I've read, I have never read one where that was true, where it was 100% one-sided. So there's almost something you or they can do to make life better and make it a little harder to fail in exactly this way. Okay, we did our ARs, we did our shared monitoring, we're doing some joint operational rigor, that's all fine. If you've gotten this far, you've got a customer that's really working well with you. They by default, having done these things, they have a more reliable system. It's a metaphysical certainty at this point. So now you're ready for stage 4, which you won't get to with all your customers. Joint on-call. This is where rubber and road meet and where the skin gets in the game. What does this mean? It doesn't mean you are running your customer's system. It doesn't mean you are deploying their binaries. No, because you're crossing a corporate boundary. It's just not likely to be true. But it does mean some things. It means when they spin up a war room at 3 in the morning, someone from your org is joining to lead debugging from your side and mitigation and remediation from your side. This is actually a really important thing. You know, at the end of the day, we like to talk about systems, but systems serve humans, at least currently. I believe Bill Gates or Peter Thiel, maybe that won't always be true. And humans get nervous. Humans do not like talking to vacuums. When a human has to wake up at 3 in the morning and gets the sense that maybe we are contributing to a problem they are experiencing, they get grumpy that we are not there sharing the pain with them. This is an important cultural step to take. This, above all else, is the step that turns a bad moment into a trust-building exercise between you and your customer. I cannot tell you the number of times we've had an incident of some kind, and we get in a war room at dark 30 with a customer, and we sit with them, and they help them resolve it, even if all our contribution is just helping them narrow down the change they made that broke it, and at the end of which they exit saying, I have more faith in you. I have more faith in your reliability than I did before, even though it just broke in some way. It's a very human thing. You need to do regular DIRT and Wheel of Misfortune exercise. So DIRT, disaster and recovery testing. If you were here, the chaos engineering things, this is sort of similar. DIRT is a thing we do in Google where we break things in production without telling people and see what happens. That's the oversimplification. It's actually a much more controlled thing. usually, sometimes not. Those that then turn into post-mortems. If you don't go quite that, but this is a really important thing to do, right? That you at least have to do wheel of misfortune. That's kind of everything up to actually pulling the cable. We do it in a particular way where we sit down with the teams that have to talk to each other. We have a proctor who knows everything, but only spoon feeds information. Like the proctor might look at the customer and say, you see a 36% increase in the median latency. So you go from 100 milliseconds to 136 milliseconds in median request latency. What do you do now? And it goes on and the proctor doles out a little bit of information. It's to get people in the rhythm of exchanging information with one another and troubleshooting together. If your company permits it, not all of them do, with some of your partners, do joint projects. Joint tooling is a great thing to do. You can contribute it to open source if that's a thing your company will permit you to do. I know that not all do. Software engineering is not the only kind of project you can do. The definition of a project, at least for me, is a thing that after you have done it, it will be easy for the next person to do. Software engineering is obviously true for that, but writing a great playbook that then someone can follow so you don't have to reason from it from scratch is another kind of a project. But this is a good way to build engineering communication back and forth. With teams, you should try to do it if you can. Just to reinforce, right, many people probably heard the expression, you train like you fight because you will fight like you trained. This is the earlier reference to it, and it's true. This is why it's important to do these kind of joint operation things. You've got to train with your customers. It makes you better, it makes them better. It also catches problems earlier, so they don't have reliability incidents. Somebody's got to go first, right? This is kind of nutty. I'm suggesting we take SREs who are sort of valuable. Not sort of, they are. They're valuable and rare. I don't know any company where the ratio of SREs to developers is less than 8 or 10 to 1, in the other way, or 1 to 8, 1 to 10. So it's a rare commodity. It's hard to hire for. I'm advocating that you actually take some of those people and point them outward at customer systems. Someone's got to go first, so that was us. We did it. We started in the summer unofficially with Pokemon Go and announced it officially in October. We call it Customer Reliability Engineering. I'll give you the quick TLDR on it just so you know what it is. What is it? We are a group of Google SREs. Right? SREs, like any other Google SRE, same job ladder, same family, same promo, per cycle, the whole deal held to the same standards. The difference is we are pointed outwards at customers instead of inwards at our internal systems. So we take joint operational responsibility for our customers' production systems running, in this case, on Google Cloud, but really any of our platform systems would be true. We're a little strange in that we are people who are comfortable talking to customers. As we all know, when we hire engineers, SREs in particular, we are optimizing for people comfortable talking to machines, not necessarily people comfortable talking to humans. But believe it or not, they exist, and I suspect you will find many of them in your organization. People actually get energy from talking to customers. Very important concept in SRE, same as any SRE team. Project work, especially software development, got to be at least 50% of the time on the team. In my team, a lot of that project work is in the course of figuring out how to open source and externalize existing Google SRE tools, things that we think would be useful to customers, but there are plenty of other really great things you can do. Obviously, a chunk of the time in the team are doing ARRs. Really, you should think about the time on your team as either doing ARRs or building things that make ARRs easier the next time. That's the takeaway there. Oh, another thing we do as a team, a lot of it, but we're getting there, is we are at a place where we're growing super fast, like our cloud business is growing very fast. So we're hiring lots of customer-facing humans, sales engineers and solution architects, whatever. We think it'd be just spiffy if the things they propose to customers and designed on a whiteboard had good reliability principles built into them, like please don't design spots. Those are bad. So we do office hours and design reviews. You may or may not choose to do that. We look at it as a preventative maintenance so that we don't see that problem later and have to unwind it. And then, of course, we spend a lot of time building and maintaining shared monitoring. By the way, we build the shared monitoring. That's our choice. We do that, not the customer. The customer contributes metrics and SLOs and business requirements, but we build and maintain the monitoring. Why? Okay, well, this may be a cultural thing at Google. I need internal SRE teams and support teams to trust the data. And for them to trust the data, the best way is for me to say, Google SREs built this system. You can count on this data. Your mileage will vary. That may not be a constraint under which you need to operate, but it is I find it's very healthy here. I just don't get arguments from the from the backline squeeze, the software developers, or the internal SREs if they were using our shared monitoring. Because they're like, oh, okay, God, I can trust this data. Cool. Next thing I hear from people, oh, yeah, this is like professional services, right? Sounds kind of like ProServe. Yeah, wrong. No, it's not. Professional services absolutely, positively, 100% has its place in the world, and I'm sure many of your companies do it or will be doing it, and it's goodness. It's good for customers. This ain't that. No. This is a thing, in my opinion, and it's the way we structure it at Google, for which you oughtn't charge extra dollars to your customer, because by not charging extra dollars, it gives you the right to come to the table with strong opinions, which you will need to influence behavior. As soon as you charge dollars, it becomes work for hire. When it is work for hire, an argument winds up getting settled by, well, they're paying a big professional services bill, you'll do what they say, right? And you lose the ability to hand back the pagers, as we like to say in SRE. We can argue about whether this is true or not. This is the way we've decided to design it. Okay, so maybe the next question is, I don't know, does it work in any way? Yeah, I'm not going to get into the success cases. I have a link here. We will put the presentation up for everyone to download. Pokemon Go was a thing, and it worked really well. Home Depot just announced themselves last week as a SRE customer. Also a thing. Also, you can go look it up. Lots of press coverage. I don't need to belabor that point. So, quick TLDR. Everything is a platformer or is going to be, whether you like it or not. The most important feature of your system is its reliability. The most important measure of reliability is the perception of our users of that reliability, which leads us to the inexorable, inescapable conclusion that we have to SRE our customers because they just can't get the 4 nines minimum that they're going to want out of those things unless we have some kind of shared operations. If all of your customers only want to build 3.9 systems, mostly you don't have to do this, but yeah, you're going to have to. Because the bigger you get, the more valuable you are, the more valuable they are, the more they're going to need that reliability. We do it at Google. It's pretty new, only about 6 months old. We call it SRE, Customer Reliability Engineering. We staff it with SREs with the genetic mutation of like to talk to human. We have a genetic screen for it, a little thing in my neck. Anyway, that is the quick TLDR summary. I know that was a bit of a fire hose. The key thing here is you cannot, right? Spes concilium non est. Hope is not a strategy. Do not hope your customers make well-reasoned design decisions or have well-reasoned expectations of you, because you will be disappointed every single time. It is not theory. We are doing it, and you can do it too. I have not been watching my time carefully. Liz? Liz gave me 5 minutes, and I'm done. So we can do Q&A for 5 minutes, and you can completely bother me at the reception too. David Blank Edelman has a question. So, Mr. Edelman, sir.
So I would like to ask you a joint on-call question.
Yeah.
So one of the traditional virtuous cycles of SRE is the notion that if your on-call or your operational load goes above a certain amount, that on-call falls back to the SWEs. In SRE, where does that fall back to?
It falls back to your partner on-call team, and what you're doing, you're using that as a lever to encourage them to make it fall back onto their back-end SWEs.
So it falls back onto your customer's on-call team?
Yep, because that's as far as your leverage, direct leverage extends. But what winds up happening is they go, oh, this is more toil than we want. And we go, well, the way we solve it internally at Google is 10% of that ticket load goes back, that's the usual rule of thumb, goes back on your developer teams. We feel like that's a cultural change you should make. And then they have incentives to make that cultural change. And we see that. It's happening. It happened at Home Depot. It was a good example.
Cool. Thank you.
Sure. Yes, sir. Oh, sorry. We're going to go side to side. You, sir. Okay, so we did some process engineering here at Google. Your mileage will vary. The way we did it is we do what's called a little internal sausage, so this is a PA funding model. My headcount and budget for this program come from the sales team, because this principally benefits customers. Which takes me out of the business of deciding which customers I interact with and which customers I do not. It's a black box. Our head of sales he does a stack rank and decides. And he might choose, it's based on revenue, or it might be based on the value of the logo, or it might be based on some interesting proof point for a workload on the thing. I don't know, and it's kind of a giant pile of I don't care. What I do have, however, if you're going to do a PA funding model, a joint funding model, the thing I insist upon, and thankfully they let us have, is a veto. I call it the willingness veto. So he stack ranks it, we go down the stack rank, we talk to everyone, we try to make a quick thumbnail assessment. Do these humans look willing to take strong opinions from us and engage in this kind of process? Like, I don't care where they're starting from. If you give me a membership to a gym and access to a personal trainer, the thing that matters is not how out of shape I am, which by the way is a lot. What matters is how willing I am to go on the diet and push the weight. Same thing. If they're willing, we'll engage. That's the sole test. That's the only veto we have. So that's how we resolve that tension. I, David K. Rensin, am not in the position of deciding who gets this and who doesn't. The next obvious question is, how do we scale? Our plan to scale is through partners, two kinds of partners. The first one, obviously, is a service partner, right? Find a qualified service partner that you can teach to do this work to your standards. Do not roll your eyes. I tell people it's foolish to think you can't do that. Of course you can. We don't genetically engineer Google SREs. We hire them externally. They do. People with the right raw material exist in the wild. You just got to put the effort in to locate pockets of them. Don't hire them all, right? See them and let them be in your partners, and then set them off. But then you have to have a backstop, and you got to audit that. And we're just starting on that journey. The second kind of partnership you have to have, however, is a technology partnership. Customers will bring their own technology choices to your platform. So what you want to do is go to those vendors, right? We announced one with Pivotal, so I'll just use that as the example, where we went in and did all the things, all the ARRs, all the reliability things on the platform, and are helping them engineer the platform so that like SRE best practices are the default installation choice. So that when your customers come to your platform with a technology choice, like they get the first third, if you will, of this engagement for free, just in having chosen a vetted, if you will, technology. So that's how you scale.
So my question is, today we're seeing more usage of platforms when we're building applications. So I can be a Google Cloud, I can be using Datadog for my monitoring, I can be using some sort of email service.
Indeed.
So suppose we get to a point where all of these organizations have their own CRE model.
Yep.
Do you envision a future where an incident happens at one organization and we have 5 CREs jump in? Because the concern then, I guess, for me would be envisioning, like, what if there's too many cooks in the kitchen?
Yep.
And so what do you envision, how you think that's going to look?
I think the very greatest thing on the whole earth for all of us is if everybody decided this was a thing they wanted to do, and then as happens when everyone rushes into a thing, eventually a group of them decide that working together is better than fighting each other, and we come up with best practices and standards. It is an unsolved problem, but it's one we are anticipating coming. I hope, like RM and Cloud, I hope Amazon and Microsoft and IBM want to do this. Last question to you, sir. Yeah, that's kind of the point behind having the technology partners, right? Those are your third-party dependencies. So in your example of it's Datadog that's there, it'd be a very useful exercise for us to go and work with them to take a fresh perspective on those things for them, and for them to come and do the same thing on components of our cloud. The answer is yes. Okay, I am out of time. I will exist for some time in the reception, so feel free to accost me there. In the meantime, I think Liz and Kurt have some announcements, perhaps? You need this? You may, of course. Thank you all very much.
Before we do give our announcements, thank you, Dave.